Dear students, I hope you all are well and studying in your home. Today, we started a new chapter, Chemical Reaction, in which you learn about characteristic of a chemical reaction. Okay, first we read about this, and in this chapter, you will be learn about different types of chemical reactions also. Okay, so you already know about the physical and chemical changes as you read in previous classes and chapters. So, which change, physical or chemical, can be represented in the form of a chemical equation? Okay, if we want to represent any physical or chemical change in the form of a simple chemical equation, so for this, we have to learn about the chemical reaction. A chemical change that take place when elements or compounds react with each other under different conditions to form new products, other elements or compounds, is known as a chemical reaction. Okay, so it is another term for a chemical change. If someone say about chemical change or chemical reaction, these are both same things. Okay, so basically in chemical change also new substance is formed, and in chemical reaction also. So always whenever a new product is formed by the combination of when different elements and compound react, okay, the changes or reaction will be called as chemical reaction. Thus a chemical reaction is process by which chemical bond are either formed or destroyed to form new substances. Okay, as we know that every substances is held by a chemical bond. Okay, if we break down these bonds, then new substances will be formed. Substances involved initially in a chemical reaction are known as reactants, and substances formed at the end of a chemical reaction are known as products. So if substances involved initially in a chemical reaction, okay, these are called reactants, means those elements or compound which react with each other are known as reactants, and the product, new product which is formed, or the end product, is known as products. The representation of a chemical reaction using symbols or chemical formula for the reactants and products is known as a chemical reaction. Okay, sorry, chemical equation. Okay, about chemical equation you already learned in the previous classes. So a chemical equation, if is can be said to have two parts, the left hand side and the right hand side. If you remember, you already know it. Reactants with a plus between them, and written on the left side, products with a, okay, plus between them, are written on the right hand side. The left hand side and the right hand side are differentiated by an arrow. If you see by this example, who forget this, now you will be remember that these two, calcium and oxygen, are reactants because these are react with each other, and it, the product is formed calcium oxide. Okay, and it differentiated by an arrow in between them. Okay, so this is a chemical equation. In the given chemical equation, calcium and oxygen are the reactants and the calcium oxide is the product. In keeping with the principles of atomic theory, the number of atoms present on the left hand side of a chemical equation must be equal to the number of atoms present on the right hand side. Okay, I already told you in the last chapters. Thus, a chemical equation can only correctly represent a chemical reaction if it is balanced. So, balance means you can see here are two molecules of calcium or two atoms of calcium, okay, are react with, okay, one molecule of oxygen and form two molecule of calcium oxide. Okay, so you can see if we just write Ca plus O2 CaO, this won't be a chemical equation, or you can say balanced chemical equation. So for balancing this, we have to add two molecules here of calcium. Okay, now we move to the characteristic of a chemical reaction. A chemical reaction may show many, so any one of these characteristics. First is evolution of gas, second change in color, third, formation of a precipitate, and next, change in state or change in energy. Okay, from these changes, okay, if any one characteristic we saw, then we can say that here chemical reaction is take place. So first is evolution of gas. Gas is evolved in certain chemical reaction. The formation of gas is indicated as bubbles if the reaction is taking place in a liquid medium. Okay, the evolution of a gas in the form of bubbles is known as effervescence. Okay, effervescence. So if gas is evolved in the form of bubble, the process is known as if effervescence. Okay, when sodium, potassium, magnesium, or zinc is dropped in an acid, hydrogen gas is evolved. The gas released is indicated with an upward arrow in the chemical equation. So you can see here sodium, okay, in this reaction sodium and hydrogen chloric acid react with each other, and sodium chloride and hydrogen gas is released. Same for other metal, magnesium and zinc also. Okay, if we react with acid, they release the hydrogen gas. When a common antacid, okay, when a common antacid composed of sodium bicarbonate and citric acid is dropped in water, carbon dioxide gas is released in the form of bubbles. Okay, so you can see that sodium bicarbonate, which is an antacid, and it reacts with hydrogen, okay, acid, and it release the carbon dioxide in the form of bubble. So you can see, okay, hydrogen bubbles in shown in when any metal like sodium, magnesium and zinc react with, okay, and when antacid react with in water, and it release the we react with acid and it release the carbon dioxide gas in the form of bubbles. Okay, uh, if you want to observe this reaction, okay, to observe effervescence in a chemical reaction, you have to require some one test tube, baking soda and vinegar. Okay, so first what you do, take a pinch of baking soda in a test tube, add a small amount of vinegar in it. Okay, you can see it figure also. Brisk effervescence is observed when vinegar is added to baking soda. So you can see the chemical equation, and when the bubbles are raised here, it means carbon dioxide gas is released. So you can write this equation like this. So now we move to the change in color. Certain chemical reactions result in a change in the color of reactants. When copper carbonate, green in color, is heated, copper oxide black is formed along with the release of carbon dioxide. Okay, you can see in figure also, figure 4.5, heating of carbon carbonate. So it's a simple reaction. When you heat this carbon carbonate, which is green in color, it turns into black in color. Okay, and it change into carbon dioxide. So this is a reaction also given here. Copper carbonate, CO3 green in color. Okay, it forms copper oxide when it is heated and carbon dioxide gas is released. Next is formation of precipitate. In certain chemical reaction, a precipitate is produced. A precipitate is an insoluble solid formed during a chemical reaction. It is indicated by a downward arrow. Okay, whenever you see in a reaction this downward arrow, it means you can see in this here. Okay, when ferric nitrate react with sodium hydroxide, it forms a precipitate of reddish orange color of ferric hydroxide. Okay, so here precipitate is shown in downward arrow. Ferric nitrate reacts with sodium hydroxide and forms ferric hydroxide in the form of a reddish orange precipitate. We already read this. Next stage which can be occur in a chemical reaction is change of state. In certain chemical reactions, the state of reactants changes. Hydrogen gas and oxygen gas combine to form liquid water. Okay, you can see that 2s2 plus O2 2s2O. Okay, this hydrogen gas is when you can see that when hydrogen and oxygen are contrary in their characteristics, but when they meet with each other, they form a different form, which is liquid water. Okay. Energy change. There are many reactions that are accompanied by a change of energy. This change of energy is usually in the form of the absorption or release of heat. If the reactions that involve the release of heat are known as exothermic reaction. For example, when a paper, wood or coal is burnt, it undergoes a chemical change and release a large amount of heat. If you see carbon plus oxygen, okay, when we burn carbon, okay, it forms a carbon dioxide and heat is released in this process. Okay, certain exothermic reactions also involve light. For example, when light and heat are produced when magnesium is burnt in air. So if magnesium is burnt in air, it releases magnesium oxide and a large amount of heat is evolved. Next is the reactions that take place with the absorption of heat, or you can say that required the heat, okay, to initiate the reaction, are known as endothermic reactions. For example, in photosynthesis, plants use the energy from sunlight, water, and carbon dioxide to produce glucose and oxygen. This is very simple example. Another example is reaction between sodium bicarbonate, which is known as baking soda, and citric acid found in lemon. When the two are mixed together, the temperature of the solution decreases and it becomes cold. This is because reaction result in the absorption of heat. Okay, whenever we get any substances which uh, cold, which become cold, it means absorption of heat is take place at that reaction. Okay, some other examples also given, you have to read this. Okay, and if you find any confusion or difficulty in understanding some words or anything, so you can ask me anytime. So I hope you like this video, and if you have any queries, you can ask me. Thank you.